Okay, so this is a base plate or mounting plate for my Vaportrail Blade X arrow rest. So what I want to do is I want to make a new mounting plate that will allow me to that'll allow me to adjust the rest higher than this factory bracket is able to go. So it looks like a pretty simple thing to make. There's a couple of things to take note of. Let me see if you can see the edges here have a 60-degree angle. It's almost like a dovetail kind of a fit here. So we're gonna have to make something for that because I do not have a cutter for my mill that would really enable me to make that easily. And even though this project is kind of archery related, I'm going to try to include a lot of machining information in here. I'm going to try to utilize my digital readout, use some of the features that are available with it. And so, anybody watching who's not necessarily into archery could maybe pick up on some of the operations, learn something from it, or if somebody has a comment that would want to leave that I could learn from, that would be beneficial too. So this will probably be a multi-part video. So all right, we'll get started in a little bit. Hope you guys enjoy it. Okay, so what I'm going to do is I got a center drill here. Now this is not the greatest center drill, it's kind of dull. So I'm going to grind this down, and that's a 60-degree included angle. So 30 degrees on each side. And I'm going to grind this down, and I'm going to make a a cutter that'll go in the milling machine, and I'll use this to cut that 60-degree angle. So all right, let's get going. You can see it. Okay, so using my height gauge, I transferred the important dimensions over to my piece of aluminum here, and what I did was this is already milled off square, and I put it up against this angle block here to keep it perpendicular.
and just set my height gauge to the variant heights and scribe some lines. And that's just to add a reference, so when I go over to the milling machine, I keep track of what is a hole, what will be a straight slot, what will be the angled face, where the holes are here, the beginning of this mounting slot, and so on. So we'll get the piece up in the milling machine, and I'll bring you back in a couple of minutes. Okay, so with my edge finder, found the edge of this, zeroed out my x-axis on the DRO, went in 100 thousandths because this is 200 thousandths thick, and re-zeroed it. So now I have, right now the spindle is right at the edge of this piece, and I got to move in 22 thousandths, and well, there's a 22 thousandths of an inch lip in here, and that's where I'll come down and start cutting that that angle. Okay, so I'm in 22 thousandths according to my digital readout, and I zeroed out the z-axis. I came down, touched this on here, zeroed this out. Now I got to come down a depth of 76 thousandths of an inch. So I'm gonna take about 20 thousandths at a time on that, and let's see how that works. Let's get down to 0 here, going the wrong way, and okay, 0 is right about there. So okay, so I'm going to come down, like I say, let's do a 15 thousandths of an inch cut. Now we're experimenting with a center drill that I modified, so I don't know how that's really going to work. So let's take a 15 thousandths cut and see where it goes. Now I'm going to decline milling on this, so I'm not going to take that deep as a cut. Now let's go for 40. Let's go down to 40,000. Let's go down to the 76 I gotta go to. shut that off and bring in a little bit closer here. Okay, so I don't know if you guys can see, but I put an angle in there. Now there's a little bit of a burr on this, so I got to move this over and run a straight 1/8 inch end mill across. So when I do that, I'll come back and I'll just flatten that little lip out over there. So I'm pretty happy with how that came out. Okay, so I got the 1/8 inch end mill, moved it over, and just double check. I laid this on here, and so as you could see, this end is the left side of this slot is a straight, and I'm going to cut some clearance in there, and then when I'm done, I'll just take this little bit off. I'll flatten that out, and then I'll come back with my my improvised 60-degree chamfering bit, and put that other angle in there. All right, let's go. So, okay, I think that's going to be good. I think I'm going to call it a night. Got to drill a couple of holes in this. Now, the original one only has one hole. I'm going to put 3. That'll give us a nice wide adjustment range above and below. This is a 10/32 thread, so we need to drill a number 21 drill. So I'm going to use the digital readout here. We're going to locate the very center of this piece. So I'm going to start by finding the edge of it here, zero out the y-axis, then come over here, find the other edge, and hit the half function key, and we'll bring the y-axis back to 0. That'll bring the spindle in the center of the workpiece in the Y direction. So let's get going. It kicked out there. I'm going to 0 my y-axis. Come back in here. Alright, right there. And now I'm going to hit half and the y-axis. Get this out of the way. And I'll bring this back to this is 0. Right there. Okay, I'll change out my edge finder for a center drill, and we'll get started drilling. Okay, so I think I mentioned earlier I was going to drill these holes here in 1/2 inch on center, 1/2 inch above and 1/2 inch below, but I changed that to 3/8, which is 375. So I went ahead. The center hole is drilled and tapped. The other hole here is drilled and tapped. So now I'm going to move the table in, and that would be center, and now 375 in from here. So okay. Bring that back a little bit. Okay. Okay, so got this centered, got the table moved in from the edge, 649 thousandths, and I'm going to start making the pilot holes there. So like I said, these are got to go down 151 thousandths. So okay, and that's a 7/64. I need 1/8 inch, but I'm gonna ream it with my 1/8 inch reamer. Okay, so I'm gonna move the table in the Y direction, 151.5 thousandths forward and backwards, and like I said before, we'll do 5 holes. So I'll bring you back when that's all done. Over here and see what we got. Okay, so I don't know if you guys can see. 1, 2, 3, 4, 5 holes. And so that gives me 5 different adjustment ranges. This will fit in like this here, and the 10/32 screw will come down here. Just gotta clean that up, pull that crap out of there. like that. All right. Okay, so we gotta make a 5/16 slot in here, and this is going to be from the edge to the beginning of the slot, a distance of 838 thousandths. So now we got a 5/16 diameter cutter, end mill in there. So we got to take into account the radius of it. So we have to add that radius to it. So what we do is go into the calculator mode, and so we put in 838, and we have to add the radius of 5/16, which is 5/32, which is 156.2. Gives us 9942, and so we'll move the table over to that reads 9942. Okay, calling that good enough there. Okay, all right, so we'll bring you back when we're ready to start cutting. All right, so I got 5/16 drill bit now. I'm just gonna drill a hole to get the end mill started in there. So. Okay, so I'm cleaning all this stuff up, and I'm gonna go grab a 5/16 bolt and check that for clearance. I can't find the bolt here, but this is a 5/16 fine thread, so pretty nice. I like it. Okay. So, all right. A couple of things left to do, really, and these tapped holes here are for like a locking set screw that you put pressure against the side of the riser to keep this from, loosening up and maybe rotating. So, a lot of times I don't even use those. I don't know if I'm going to put them in or not. I'm going to take a break. This will be it for tonight.